Now, we need to understand how to solve absolute value inequalities. We've already done absolute value equations. So for example, if I said right now, the absolute value of a number equals 5, I have two possible answers. What's one possible answer that would work for this? So somebody said 5, somebody said -5. They would both work. If we were to do a solution set, we would say a -5 would work and a +5 would work. And this is dealing with an absolute value, not inequality. This was an absolute value equation. What we're going to do now is we're going to do absolute value inequalities. So if I said the absolute value of x was greater than 2, all right? We want to figure out how could we solve this, all right? And how could we graph it? Now, over here, how many answers did we have for this one? 2. We had 2. How many answers do you think we're going to have for this one? 2. We're going to have 2 answers, okay? Now, one of your answers is going to be what's known as the positive version of the answer. So, over here, the absolute value of x equals 5, what was one of our answers? X equals 5. So if I say the absolute value of x is greater than 2, what do you think could be one possible answer? 2. X is not just 2, but x is greater than 2. Okay? So one answer is x could be greater than 2, and that would work.
Really? I never would have thought that.
We could have greater than that.
That's right. Andrew just said, is x also less than -2? And I said correct. Now notice, what happened to this symbol?
It flopped.
It flopped. All right, so this inequality sign, all right, the sign flips or changes because you applied a -2. Because of the -2, what happens to the sign? It has to change. Okay? So the sign flips because we have because of the negative, right?
So,
because of the negative. Go ahead. What was your question?
So if we flip it, you'd have 2 answers and be the exact same thing. It would be x greater than 2. For the second one, you have x is less than -2. You flip it.
And so we're gonna have 2 answers. Okay, one's this one, one's this one. We're gonna graph it, see what it looks like. So get a number line. So make a number line on your paper. Okay, going this way and going that way. All right. Right now, just put 0 right there in the middle. So we have 0 here. 1, 2, down here -1, down here -2. So go and plot that right there. Now, if we plot x is greater than 2, what kind of circle are we going to be dealing with? Empty, right? It's going to be nice and empty because we're not including the 2. And where are we going to shade this one? Which one? If you say that way, that means going to the right. So we're shading everything to the right because x is greater than 2. All right? What about this one over here?
Circle.
You have a circle?
Everywhere
Everywhere to the left. So everything here is now going to the left. This is an example. Yeah, this is an example. By the way, this is what's referred to as an OR compound inequality. Compound means you have more than one inequality that you have to graph. We're graphing 2 inequalities, all right? So think about it. What's a compound versus an element in like science class? Yeah, so for example, salt. What's salt made out of? Sodium? Nope. That is a type of. Just table salt. Sodium chloride. NaCl. Chlorine and sodium together makes sodium chloride, which is table salt. Okay, that's a compound. Yeah. What's an element? An element is sodium. An element is chlorine. A compound is together. So we're dealing with a compound inequality. You're dealing with 2 inequalities working at the same time. Okay? So this is an OR statement. Now, what I'd like you guys to do right now, by the way, if I say graph the absolute value of x is greater than 2, this is the graph of it. That's what the graph looks like. Now what we're going to do is I want you to do another one. Here we go. The next one I want you to put on your paper is the absolute value of x is less than 3. That's what we're going to solve right now. The absolute value of x is less than 3. And what we're going to do is we're going to make another number line. And this time, we're going to start with 0. We're going to go all the way out to 3 and all the way over to a negative 3. Okay, so go ahead and get that on your paper. All right, if we wanted to solve this, how many answers are we going to have? Well, 2. What's one of the possible answers that would be true? Be more specific. X could be less than positive 3. And what's the other one?
X could be less than, greater than, negative 3.
That's right, greater than negative 3. Now, why does the sign change? Because of the negative, right? So remember, the sign flips with the negative. Okay? Let's think about how we're going to graph this. Once again, where are we going to have an open circle? We're going to have an open circle here at a
3.
positive 3. We're also going to have an open circle here at the negative 3. Now, here I have to go less than, correct? Which means I have to start traveling which direction? To the left. Over here, I have to start going greater, which means I have to start shading
Right.
to the right. What happens? They over... This is an and statement. Whenever there's a boundary on either side, all right, and everything's shaded in between, that's an and statement, okay? So we're going to write the word and. So with your notes that you wrote down in your journal, hopefully this will help you guys understand a little bit better, all right? Look at the table that you guys drew right here. Look at the and statement. An and statement is when things are what? In between. An or statement is when things are going on opposite directions. All right, you're going this way or you're going this way. That's called an or statement. When it's everything in between, it's an and statement. Okay? So let's look at number 1. Zoom in on number 1. Okay? Zoom in on number 1. What does it say? It says
All numbers are greater than or equal to what?
Let me zoom out just a little bit. There we go. Sorry. There we go. That's a little better. So it says all numbers greater than or equal to 2. So how do we write that? All numbers greater than or equal to 2. That's 1 right there. So I'm going to highlight that part, everybody. Where it says all numbers greater than or equal to 2, that's what it's referring to. You can write that down on your paper. This is number 1. Okay. Or, what does it say? It says or.
Less than or equal
All right, so we're going to say for x is less than or equal to a negative 2. So that's the other one. And the key word is what? It's or. So the first one I'm going to do, it says equal to a 2, so I'm going to do a closed in, everything, because when I close it in and I'm shading it, what does that let me know? That means I'm including the number. And right here, I'm also including the number as a negative 2. Now, which direction am I going to shade from here?
Right.
Going here to the right, because it's greater than 2. What about this direction? Left. All or statements are going to be going in opposite directions. Now, Shane, this one said not just do this, but it said what? Write an absolute value inequality that matches this. Now, let's go back and check this out. Do you guys see this inequality? Does this one look relatively similar to the one we just did? What's the only difference between this one and this one? The equal to. The equal to. So the symbol. So this one, their final answer for number 1 is the absolute value of x is greater than or equal to a positive 2. This is your answer for number 1. Okay? you guys to understand that whenever you have things going in opposite directions, you're going to have a statement that starts with greater than. Whenever you have a statement where it's in between, the and statement, it's going to be something that's less than. Okay? So let me go back, let me make sure everybody's clear on this. Okay, so I'm just going to do a quick little picture. All right? If you see your graph has like a filled in circle, or I'll just do arrows. If you're going one way or another way, like this, if your graph looks something like this, or they're both filled in, you're going to have the absolute value of x is greater than some number. Okay? However, if you have, let's say you have a closed in, it's all closed in here, and it's all closed in right here, and everything ends up being shaded in between it, like that, it's going to be the absolute value of x is less than a number. Let me tell you where the number will be. It will always be the number on the far right. All right? So whichever number you use, always use this number. So for example, this is a 2, and this is a negative 2. I'm going to say x is greater than a 2. If this right number here is a 5, and this happens to be a negative 5, then this would be the absolute value of x is less than 5. So always use the number that's on the far right when you're writing these equations. Okay? So let's apply that real quick. Scroll down to number 5. I know you haven't done number 5, but scroll down to number 5. All right? Is this an and? First of all, is this an and or an or statement?
Or and.
It's an and statement because everything's shaded in between. But an and statement. Okay? Look at what's the number right there? It's the number 1. It's not including it. So let's go back to what we just did. This one or this one? Which one? Top or bottom? Bottom. So x is what? Less than. So here it's going to be what? The absolute value of x is less, not equal to, but just less than 1. And I think I made a mistake real quick. Hold on. Oh, I did. That should be an equal to sign. My bad. I apologize. So if you're watching the video, I did eventually correct myself. Eventually. That should be equal to. This one is not equal to because it's open. And this would be your answer. When it says, write an absolute value inequality for each graph, this is the absolute value inequality for number 5. Okay? So what I'd like you guys to attempt to do is attempt to do the first 8 problems. All right? You'll have more time to work on it tomorrow. Well, what do you need to get done tonight? If you haven't finished your 1-5, make sure you get that done tonight.